Welcome back, students. Today we shall see regarding chapter biomolecules. Under that we have started proteins. We know that proteins are compulsorily said to be arrangement with the help of amino acids. Alpha amino acids are going to be bind each other to form the peptide linkage, and we consider long chain of amino acids is said to be giving us structure for proteins. So that is long chain of alpha amino acids to form alpha amino acids bind each other by peptide linkage will give us a structure of proteins, Okay. So, how does that peptide linkage is going to form? We have to check out. Peptide linkage is going to form when we consider two amino acids are going to react each other. There is elimination of water molecule from the carboxylic group of from the hydroxyl OH group of carboxylic group and hydrogen of amine group. Together they will be left as a water molecule to form a peptide linkage. So, for example, I will be taking an amino acid here. See, I have alpha amino acid NH2, then I have COOH group and is going to be combined with another amino acid in which I will be having NH2. Okay. So, this is further is being bonded to any different substituent groups. So, here I will be having COOH. This is two amino acids of alpha form I have considered here, and together they are going to eliminate a water molecule. On heating they will be giving liberate water molecule to form a combination or bonding between carbonyl group of one amino acid and amine group of other amino acid. So, how does the structure will be looks like after the bonding? It will be like CH, H, then I have C double bond O, NH bonding is going to take place due to provision of lone pair of electrons to the carbonyl group. When lone pair electrons given to the carbonyl group, binding is going to take place and it will become a structure of protein in which these two amino acids, amino acid 2, amino acid 1 together they have formed a dipeptide type of amino acid, in which this linkage we will be calling it as dipeptide linkage. We call it as dipeptide linkage because two amino acids are in combination, they are giving us peptide bond. As two are only involved here, we will be calling it as dipeptide linkage. Similarly, as I have taken only two amino acids, in order to make the polymer, that is many amino acids combine each other in the similar fashion. Say for example, I have taken A, I have taken B. Similarly, plus I will be taking one more amino acid in which we will be having a NH2 group, and that amine group is going to provide its non-pair electrons to the carbonyl group. Again elimination of water molecule is going to take place to form the next tripeptide linkage. As two amino acids combined, dipeptide, 3 amino acids combined, tripeptide, 4 tetrapeptide. Similarly, n number of amino acids combine each other to form a respective structure of the proteins is said to be due to polypeptide linkage. That linkage we call it as polypeptide linkage. Let us see how does that polypeptide linkage is going to form. See here, I will be having number of amino acids. Say for example, we know all the amino acids in the structure of the protein are generally existed in alpha form. I will be having alanine. We know that NH2 group, carboxylic group together will be present, and I will have glycine. Then I will be having alanine, glycine, leucine, isoleucine, and so on it goes, because we have considered number of amino acids. So, these number of amino acids together they will be forming each other by the elimination of water molecule, and these linkages which are obtained here are said to be polypeptide linkages. They are referred as polypeptide linkages. This straight line or linear polymerization is again referred to be a structure. How we write the primary structure for protein is a combination of many alpha amino acids together. It will be giving us respective structure for protein, and due to existence of number of amino acids we will be calling it as polypeptide linkage. Protein structure is obtained due to polypeptide linkage. Fine, this is the thing we have to understand. Then further we have again two types of proteins, globular proteins and we have fibrous proteins. So, those two types we understand here. Classification of proteins. When you consider classification of proteins, they are mainly two types. Okay. So, very first one I could consider it is fibrous protein, and the other I have fibrous protein and other I have globular protein, globular proteins. So, when you consider these two types we have to understand how exactly they show their structure. As name itself is suggesting us here, fibrous proteins are straight strands. These are strands which lying parallel to each other. Fibrous strands are lying each other in parallelly is the structure what we can write for the fibrous proteins. Similarly, globular means circular shape. So, these globular proteins somehow they will be coiled each other to form a globule like structure, and that is why the reason they are said to be globular proteins. Okay. Here these strands are, these fibrous strands are lying parallel to each other, they will lie parallel to each other. Okay. But in case of here amino acids are combination of polymers, they are going to be coiled around, they are coiled around each other, they coil around each other to form globular structure, to form a globular structure. This is how we exactly define the globular proteins as well as fibrous proteins. So, what are the examples we can consider here, how they are going to differ with respect to the complex structure of the proteins and all we have to check out. Fine. Okay, when you consider structure for the proteins, we have mainly of three types. The main category for the proteins structure if you have, they are mainly three types. I will be considering primary structure of proteins, and I have secondary structure of proteins, and I have tertiary or complex structure of proteins. I have third category referred to be tertiary structure for proteins. So, when you consider primary structure, it is as simple as we have done polypeptide linkage, linear polymer of many amino acids. That combination is going to give us straight chain or simple chain referred to be a primary structure of proteins. That is combination of amino acids. Combination of amino acid will form a polymer of amino acid, will form a polymer. That itself is referred as a structure for primary structure for proteins. Very simple one, they will be forming a combination of amino acids. One important thing we have to remember here in case of primary structure is that the amino acids which are obtained due to particular combination or specific combination, they will give us a specific protein. A combination of alanine, glycine, leucine give us a specific combination of protein is entirely different from that of the amino acids when they are differ. That is the main important thing, that concept or the statement holds good for all the structure of the proteins. So, when you consider particularly secondary structure of proteins is again further of 3 types we can have. So, 2 types. Secondary structure gives us alpha helix form as well as beta sheeted plates. We have alpha helix form, then I have second type beta plated sheets. These are the 2 forms are going to be existed. How a alpha helix form is going to be seen? Alpha helix form is just like this. Helical form of protein is going to be seen in this fashion. That is why the secondary structure of protein can be said that alpha helix form. As well we have beta plated sheets. Like this, beta plated sheets are nothing but they will be arranged in this manner. Just for the view of purpose, I have given 2 types of proteins structure of secondary type. Secondary structure alpha helix, beta plated sheets. Now we have to check out how does these combination of amino acids are existed and which is the binding site they have used for the secondary structure to obtain. All those things we have to check out. Tertiary structure, at least it is a kind of complex structure wherein tertiary structure contains primary, secondary as well as tertiary units together, and it will form a kind of complex structure which is generally made of primary unit, secondary unit as well tertiary unit, and it will be having a complex structure of all these together, and that is going to be referred as tertiary structure for proteins.